So welcome students. So in this question you're given that you have two lines. The first line is x by 5 plus y by b is equal to 1. It passes through the point 13, 32. And the second line x by c plus y by 3 is equal to 1 is parallel to the above line. And if that is so, what is the distance between these two parallel lines? That's the question. So first step that I do is to find the value of b. That value of b can be found out by substituting this point on this line. So 13 by 5 plus 32 by b is equal to 1. This implies 32 by b is equal to 1 minus 13 by 5, that is equal to minus 8 by 5. So minus 8 gets cancelled 4 times. So minus b is equal to 20. B is equal to minus 20. So this line is nothing but x by 5 minus y by 20 is equal to 1. Or 4x minus y is equal to 20. Right? If I take the LCM, you get 4x minus y is equal to 20. Now, it's given that this line is also parallel to the above line. That is, this line is parallel to this line. So this line, if I simplify this, you get 3x plus cy is equal to 3c. So if these two lines are parallel to each other, the slope of these two lines have to be equal. So 4 is equal to minus 3 by c. The slope of this line is 4 is equal to minus 3 by c. So c is equal to minus 3 by 4. C is equal to minus 3 by 4. So now you got the value of c. So once you got the value of c, what is the distance between these two lines? So this line becomes 3x minus c is minus 3 by 4 minus 3 by 4 into y is equal to 3 into minus 3 by 4 is minus 9 by 4. This implies if I take 4 here, 12x minus 3y is equal to minus 9. And the first line is, if I change it into standard form, so the first line becomes, if I multiply this with 3, 12x minus 3y is equal to 60. So what is the distance between the two parallel lines? The difference between the constants by root of a square plus b square. So distance is equal to difference between the constants is 69 by root of 12 square plus 3 square. It is equal to 69 by root of 144 plus 9 is root of 153. That is equal to 153 is 17 into 9. A 3 comes out. You get 23 by root of 17. So that's the distance between these two lines. Thank you.